So in the last video we talked about heteroscedasticity. Now we are going to plot the predicted spending versus the absolute residuals so that we investigate if this line, if there is a line, if there is a trend, if there is a strong R squared, or if there's a slope here that we probably can't ignore the heteroscedasticity. We also, this is the first step, and the second, the following video, I'm gonna show you how to do a Prussian and Pagan test for heteroscedasticity if visually it is very difficult for us to determine whether there is a heteroscedasticity or not. All right, so the heteroscedasticity assumption, we are gonna now proceed with it. Of course, it is the heteroscedasticity check or test. So let's get started. As you guys remember, I asked you in class that we keep here the absolute residuals before the residuals. So we moved the residuals in one column ahead, and we kept the residuals here and the predicted values. So the predicted values here should be on the x-axis. So it's good that they are ahead from the absolute values of residuals. Those are going to be on the y-axis. So basically we're going to select the both the predicted values and the absolute errors, the predicted values for Ball's sales and the absolute errors, and scatter plotted. And as you can see here, this is the predicted values, and these are the absolute errors. You see the predicted values are in 3 digits, the absolute errors are in 2 digits. Yes, that's all right. If you like doing the same way I do, please, by all means, and you also can see here the absolute residuals are here plotted in the y-axis. So please type in here absolute and here residuals. And let's make it nicely bolded. And over here, these are the predicted values, all right, or the predicted sold balls or ball sales. And here we can also give this a name, a nicer name, which is the heteroscedasticity check if you want, or test. Now what we need to do is to plot a line to see if there is any linear relationship between the predicted values and the ABS, the absolute values of residuals or errors. This is one of the tests, but actually there are other better tests than the linearity, because there might be visually, you need to see if there's any other pattern, because the residuals might be high, then low, then high, or low, low, high, or low, high, low. Something like that. So there are other patterns other than the linear relationship that the predicted values could affect the absolute errors. So this is just one of the tests that I personally, or even in our book, the book that we are using, that we look into, but there are also other tests that you need to take into consideration. Now let's take a look at the linear line. Let's put it in red because we can see it better. And as you can see here, guys, this is the line. The line is almost flat, and the R value is the R square is very small. It is 0.0049, almost 0.005. So the R square is really low. And also visually, you can see that this line is almost flat. It is not really showing a very high tendency of a relationship between or the behavior of the absolute residuals being affected of the predicted values. So with this check, we can say that the visual is visualizing or plotting the absolute residuals versus the predicted values led to an almost flat line, or horizontal, almost horizontal line. I think there's an I rather than an E for horizontal line, and a very low R square value. This means that predicted values has a very low effect in changing the values of the absolute errors, or in changing the magnitude. Magnitude is only the value itself without the sign. It's only the magnitude. So usually when you are describing a vector, if your math is really strong, when you're talking about what's the difference between a vector and the list in Python also, a list is only a magnitude. A vector, on the other hand, is a magnitude and the sign. So it has two different dimensions: the magnitude, the values themselves, and the sign, where it is directed, going this direction, going backward, and so forth. So there is an arrow at the end of the vector, right? And this shows you the direction of it, positive, negative, which direction is going. So when I say the magnitude here of errors, this means I am talking only about the value of the error without the sign. And this is what we're looking into, the absolute residuals. So if I say the magnitude of errors, this means the predicted values has a very low effect in changing the magnitude of the residuals or the error terms. And then you say, thus, visually, we can say visually, there is no evidence of heteroscedasticity. Now the visual is just enough. This visual test is probably just enough if it is all flat, and you don't have to, and the R square value is very low, and it doesn't look like there is really a big trend or any behavior here, like any specific observed behavior, changing behavior of the absolute residuals as the predicted values increases. You can just stop here. In the quiz, I will be asking you to do the heteroscedasticity check either visually or through a certain test. But for now, in this video, I'm just going to show you the visually how to check the heteroscedasticity. In the next video, I'm going to show you how to check it using the Prush and Pagan test. And this is something that is mentioned, not mentioned in the book, because sometimes I know that it can get very, very tricky. Like for example, in this visual, it's very tricky. It looks like there is a relationship. As our predicted values increases, seems like the error terms also increases. However, if you look at the R square, it's 0.3. Do you consider 0.3 strong enough? Is not strong enough? And so on. So basically, I like to use the Prush and Pagan test, and it is not part of the book. So please stay tuned. Next video, I'm going to show you how to look into heteroscedasticity through a mathematical test. However, I have a disclaimer. This test only investigates if there is a linear relationship between the predicted values and the absolute errors. There are other more advanced tests, all right, that investigate any kind of relationship. Increase, decrease, increase, decrease, decrease, increase, and decrease kind of relationships, like more patterns in the relationship rather than just increasing or decreasing. But in for bachelor students, we just cover the Prush and Pagan test. But it's good that for some students who are hoping for more advanced education, that they look into more advanced tests that investigate non-linear relationship between predicted values and the absolute errors. Thank you so much for your attention. I look forward to seeing you in the next video.